Well, Tigers are back on the bench again, literally pushing back all other projects, which are in various stages of being stalled. It's been a pretty nice summer, so I've been outside mostly, but canoe season's over, ski season hasn't started, and it's got a rainy week ahead here, so time to get some of these electronic projects caught up on. So, the big thing on this amp was the same as the last amp. The caps failed. The original old line caps failed. 4,050 volts. The new caps are considerably smaller, even though they're double the capacitance. These are 10,000. It's kind of neat. I looked around. I had to get this 35 millimeter base to fit in these old clamps. I finally found a place. These are temperature rated too, supposedly. And the capacitance is right too. In fact, it's got a brand name on them. Nippon Chemcon or something. Anyways, this company I found on eBay had 50 volt, 10,000 UF electrolytics in all kinds of different sizes. They had like 9 different physical sizes of the same value cap. So virtually any device you need to replace caps in, they had a cap that would fit it. So that's kind of cool. I did the same thing on this one, as I eliminated the PC board that was power supply PC board. And then that means I gotta have this little cap and resistor dangling, which I'll do a better job of later. I need to get a better resistor for that. Plug these back in. I also replaced the capacitor. And instead of the original cap, I put a cap with a little bit lower ESR. Probably no big difference though. Yeah, when the workbench spills over to the stools, it's really getting bad in here. Like both stools. So I've long had concerns about using tantalums. Polarized tantalum, there's nothing but like I don't believe they make an unpolarized tantalum capacitor. So tantalum capacitors are normally polarized. I'd be interested to know if anybody has seen an unpolarized one. Yet I've seen them used in applications like on this amplifier, and I've seen other manufacturers do this as well, where they'll put a tantalum as an input capacitor, even though it's a polarized capacitor, and it's being used in non-polarized usage. And that's why I'm replacing the tantalums with this guy. It's got a real low ESR, lower than tantalum, so I will do better that way. I tested the capacity using this other meter. I was kind of surprised. These tantalums are right on. I mean, the one was actually 5. These are 4.7s. The one was 5, the one was a little bit low. But they weren't that far off for 40-year-old capacitors that have been used in a non-polarized application, and they're meant to be polarized. That's pretty amazing, I would think. But like I said, I've seen tantalums used this way before. I think as long as you use them at a fraction of the rated voltage, they'll kind of repolarize, like an aluminum electrolytic can do to a degree, which is basically oxidizing both plates. Instead of just oxide all in one plate, when it's non-polarized, they oxidize both plates to get a non-polarized cap. And I think what happens is these kind of get a little bit halfway-ish. They were in the 10 megaohm range or better for resistance. They had a higher ESR than this guy, but nothing terrible. I mean, that's the only advantage I'm really getting is the lower ESR. So it's double the ESR, but it's still nothing huge. Yeah, this one's getting pretty high at 5. But not terrible. It probably wasn't affecting audio at all. And their capacity was more or less correct. I'm kind of surprised they're different colors, because to my knowledge I never replaced these. These should be the original 40-year-old caps, unless I replaced one of them. Or they just gave me, different colors. So here again is the size difference. This is 10,000 microfarads. This is 4,000 microfarads. Really have shrunk. And I did this amp earlier, with the bridge rectifier and getting the parts off the board. I'm going to have to ask Kurt if he wants these caps back. I may give them back to him because I got caps to put in here. I don't know if I can do that work right now, though, as far as converting it over to those caps. I kind of like to get these things back online. And the cap that went bad is just totally open. I can't get an ESR reading at all from the ESR meter on it. Just dash, dash, dash. It's just totally open. Same with the capacitors. It's just totally gone open. Yeah, this one contact's totally gone. Before I even rip into it any further. I wonder if that contact just rotted in half. I think it did. Interesting. I might be able to see if there's anything left in this cap. Good old Fnirsi. This is one that John Audiotech left with me. He was going to do a review on it. He was a little bit upset because they sent this along with some other stuff. And then they expected a review on it. But she didn't really request it. But it seems to be a pretty cool meter. I'm waiting for... I'll do a review on this when I've used it for a little while. I'm kind of waiting for Eddie to do his review because he's got a lot better equipment than I do. But I'll have some usage ideas on it. I'm kind of curious if I get a reading out of this cap if I get right to these tabs. Yeah, well, not much. That's nanofarads. Oh, there you go, 4.7. There. That's it. That's the capacity of this. That's it. Because millifarads is not microfarads. Millifarads is, this is like 4,000 microfarads, which is the rated value. And actually, it's above the rated value. I just lost that one contact. It just rotted away. But the cap bundle is still good in here. Maybe I can use it to open it. Use it on a project like that. Of course, it'd be kind of tough to solder to aluminum. Okay, I can get 9.8 out of this cap. So a 10 microfarad capacitor, I can get 9.8. But what if the capacitor has an ESR? This is something I've talked about a lot in message bases. And maybe I'll make a short video about it. It's falling apart. Well, not too bad. 9.82 with a 1 ohm resistor in series. I'm kind of holding it together here. I thought it would affect the reading more than that. So that's not bad. A lot of these work on a time constant. And ESR will really throw them off. Make a capacitor look bigger than it is. And you can see all the wasted space in here. I don't know if you can see the end of that. But yeah, there's quite a bit of weight. They put a big glob of tar or something in there, sunk the packet in there, didn't even get to the very bottom. So there's that much dead space at the tip. And, you know, up to a 1/4 inch on the edge there. Wasted space. Okay, I wasn't sure about that first test, so I redid it with bigger values. And actually, this meter gives me the accurate capacitance with or without the 2 ohm resistor. Either way, I'll get the same number. So, in that way, it's accurate as far as capacitance goes. It doesn't get thrown off by a high ESR. So it's accurate despite ESR. I deliberately put a 2 ohm resistor in series with the cap to give it ESR that it didn't have. Because the cap tests pretty well otherwise. You know, very low without. And of course,